The unchangeable path. This theory is pretty straightforward. Basically, no matter what you try to change in the past, the future stays the same. You can go back and mess around all you want, but the timeline will always course correct to make sure everything ends up how it was meant to. It's kind of like time is set in stone. Imagine this. You go back in time to stop a disaster, but it turns out that in trying to stop it, you actually cause it to happen. Sounds frustrating, right? But that's the essence of this theory. Your actions in the past are already part of the future, and there's no way to escape that. Movies like The Terminator or 12 Monkeys are great examples of this, where the characters think they're stopping something catastrophic, but their actions end up being the very thing that makes it happen. The real mind-bender here is the idea that maybe everything is already written. Every choice, every action, it's all set in motion and we're just playing out the script. Is free will just an illusion? Are we all just along for the ride even though we feel like we're making choices? This fixed timeline concept raises all kinds of philosophical questions. If you can't change anything, does anything you do even matter? For some, that's a comforting thought. Everything is meant to be. But for others, it's unsettling, especially if you like the idea of having control over your destiny. To sum it up, the fixed timeline theory tells us that no matter what we do in the past, time will always find a way to make sure the future stays on track. It's kind of like a cosmic safeguard that keeps everything in line, whether we like it or not. Dynamic timeline theory, changing the future. This theory says that the past isn't set in stone, and if you go back and change something, the future does change. In this version of time travel, you've got the power to rewrite history, and that can have some pretty big consequences. A classic example of this type of time travel is Back to the Future. Remember when Marty McFly accidentally changes things in the past and his whole future is altered? That's dynamic time travel in action. You can tweak events and those changes ripple forward, affecting everything that comes after. It's exciting because it suggests you're not just an observer, you've got the power to make a difference. But here's where things get tricky. You've probably heard of the butterfly effect, right? It's the idea that even the tiniest change can have massive consequences. Step on a bug in the past, and maybe that small act changes the course of history, leading to a totally different present. It sounds far-fetched, but in the world of dynamic time travel, it's a real possibility. You never know how those ripples will play out. This type of time travel is all about responsibility. If you've got the power to change the past, how do you know what changes are the right ones? What if you make things worse? That's the big question here. Just because you can change things doesn't always mean you should. At its core, the dynamic timeline theory taps into our desire to fix mistakes and shape the future for the better. It's the ultimate what-if scenario, where every action you take could have far-reaching consequences. But with great power comes great responsibility, right? Multiverse theory, infinite possibilities. Multiverse theory opens up the possibilities. According to this theory, every time you make a change in the past, you're not altering your original timeline. Instead, you're creating an entirely new one. It's like taking a fork in the road and both paths exist simultaneously but in different universes. So, in this theory, there's not just one timeline. There are infinite timelines with every possible version of reality playing out somewhere. You might go back and change something in the past, but all that does is create a new branch of reality. Your original timeline stays untouched. Imagine stepping into a world where major historical events played out differently. Maybe dinosaurs never went extinct or humans never invented the internet. Crazy, right? This concept is used in a lot of popular media. One example is in Avengers Endgame, where the heroes travel back in time, but instead of changing their timeline, they create alternate ones. In this kind of time travel, every choice creates a new version of reality. The cool part is, every possibility exists, which means somewhere out there, there's a universe where you made a completely different decision than you did in this one. But this also makes you think, if there's an infinite number of realities, does anything matter? If there's a version of reality where every possible outcome plays out, does your particular timeline even matter? It's a wild thought, and it forces you to think about your place in the universe. Overall, the multiverse theory doesn't just limit time travel to fixing the past. It's about exploring whole new worlds, each one different from the last. And the possibilities, well, they're endless. Time loop, the endless cycle. This type of time travel traps you in a cycle where you live the same events over and over again. There's no jumping to the future or past. You're stuck in a loop, reliving the same moments until something or you changes enough to break out of it. A lot of you might be familiar with this from the movie Groundhog Day. The main character is stuck living the same day on repeat, over and over again, until he figures out how to live it differently and escape the loop. Another great example is Edge of Tomorrow, where a soldier keeps reliving the same battle until he can find a way to win. What's interesting about time loops is that they offer a chance for personal growth. You're given infinite chances to get it right, to perfect your actions and decisions. At first, it's frustrating, but eventually it becomes an opportunity. The loop almost forces you to evolve, to become the best version of yourself. But here's the big question. If you're stuck in a time loop, do your choices even matter? If everything resets at the end of the loop, does it matter what you do? This kind of time travel makes you think about the value of your actions and whether or not they have lasting consequences. In the end, a time loop can be both a curse and a blessing. It's a trap, but it's also a chance to learn and grow. And if you can break free, maybe you'll come out of it a better person, or maybe, just maybe, you'll be stuck forever. Quantum leap consciousness time travel. This theory is a bit different. Quantum leap time travel, where it's not your body that travels through time, but your consciousness. You don't physically jump through time, but your mind does, taking over someone else's body in a different era or moment in time. One of the most famous examples of this is the TV show Quantum Leap. The main character, Dr. Sam Beckett, leaps through time and takes over the bodies of people in different periods, trying to fix what went wrong. It's like he's jumping into someone else's life and playing out their role. But he keeps his memories and knowledge. This type of time travel is fascinating because it's not just about jumping through time, it's about experiencing life from someone else's perspective. You're forced to adapt quickly to a new body, a new life, and a whole new set of circumstances. And you have to figure out how to fix things before moving on to the next leap. But that raises some big ethical questions. If you're controlling someone else's body and making decisions for them, is that fair? Do you have the right to interfere in their life, even if you think you're helping? It's a tricky moral situation, and one that makes this form of time travel particularly unique. In quantum leap time travel, the focus isn't so much on the science, but on the emotional and moral growth of the traveler. It's a journey of self-discovery, as much as it is a journey through time. Alternate reality travel, diverging from the main timeline. This theory is pretty wild because it's not just about jumping through time, it's about jumping into a completely different version of reality. In alternate, you visit a version of the world where key decisions play out differently, leading to an entirely different timeline. This isn't about creating new timelines like in the multiverse theory, it's about seeing how one change in the past led to a radically different present. Think of shows like Fringe, where characters explore parallel realities to stop major disasters. Or imagine visiting a world where major historical events like the American Revolution or the moon landing never happened. In this type of travel, you're not just an observer of a different timeline, you're part of it. You might even encounter alternate versions of yourself, which raises some big questions about identity. If another version of you exists, what does that say about your current self? Are you just one of many possibilities? What's also interesting is that alternate reality, the fragility of history. A single decision or event can lead to a different outcome, making you wonder how much of our world is shaped by chance. In conclusion, alternate reality travel lets us explore the what-ifs of history. It's about more than just time. It's about seeing how different choices lead to different futures, and it forces us to confront some deep questions about identity and faith. Causal loop, the paradox of self-creation. The causal loop, also known as the bootstrap paradox, is where things get confusing. In this kind of time travel, events are caught in a loop where the cause and the effect are the same. It's like a never-ending cycle with no clear beginning or end, and the traveler might end up being the cause of the very thing they're trying to prevent. One of the best examples of this is the movie Predestination, where the main character discovers they're responsible for several key events in their own life. The same kind of loop appears in Harry Potter when Harry goes back in time with the time turner and ends up saving himself. In both cases, the actions they take in the future were always a part of the past. Then there's the bootstrap paradox, which is when something exists without an origin. Imagine going back in time and giving Shakespeare a copy of his works, and he publishes them. But where did the works originally come from? They exist in a loop, without a clear point of creation. This type of time travel raises big questions about free will and fate. If you're part of a loop, are you making choices, or are you just playing out a script that's already been written? It's a paradox that challenges the way we think about cause and effect. In the end, the causal loop is one of the most mind-bending forms of time travel, where time folds in on itself, and everything you do is both the cause and the result of the same event. It's enough to make your head spin. Time dilation, traveling through time by slowing it down. This theory is grounded in real-world science thanks to Einstein's theory of relativity. It happens when someone or something moves at speeds close to the speed of light, causing time to slow down for them compared to everyone else. So, while the person traveling at near light speed experiences time more slowly, the rest of the world keeps moving at a normal pace. In theory, this could allow you to travel into the future. You wouldn't jump ahead instantly, but by the time you return to normal speed, everyone else will have aged much faster. It's like fast-forwarding through time. A great example of time dilation is in the movie Interstellar. Remember how on the planet near the black hole, time moved much slower? For every hour spent on the planet, years passed back on Earth. That's time dilation in action. It shows how time can warp in extreme environments, especially where gravity or speed plays a big role. This isn't just science fiction either. It's been observed in real-life experiments. Astronauts on the International Space Station experience time slightly more slowly than people on Earth because they're moving so fast. While the difference is tiny, it proves that time dilation is real. Time dilation is fascinating because it offers a way to travel through time, though only forward. You can't go back, and once you move ahead, there's no reversing it. Still, it's one of the few forms of time travel that's possible according to the laws of physics. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us. Curious about how space mining is transforming from science fiction into reality? As we reach for asteroids and the moon, we're unlocking resources that could reshape industries on Earth and fuel deeper space exploration. Today, we're diving into the most groundbreaking innovations driving space mining forward. Join us as we explore these awe-inspiring advancements set to change the future of space exploration, industry, and the very fabric of our economy. Robotic mining drones. Robotic mining drones are transforming space mining by autonomously extracting precious materials from asteroids and the moon. Picture small, autonomous robots traveling millions of miles from Earth, landing on celestial bodies and mining resources entirely on their own. Built for extreme environments, these drones use advanced sensors and AI to navigate, identify mineral-rich areas, and extract resources. Their precision allows them to locate valuable metals, rare minerals, and even water ice for future space missions or fuel production. These drones are lightweight, compact, and perfect for space travel, yet packed with spectrometers to analyze rock and soil composition on site. With these tools, they detect platinum, gold, and rare earth elements in the environment. Equipped with specialized drilling arms, they can mine in low-gravity conditions, carefully extracting resources without scattering materials into space. Autonomy is essential, with AI systems enabling drones to learn and adapt in real time. They make exploration and extraction decisions independently, as communication delays prevent real-time control from Earth. Capable of handling unexpected issues and even minor repairs, they ensure smooth operations. One exciting aspect is their ability to work in teams, with missions deploying fleets of drones that collaborate seamlessly. While some map and analyze the area, others drill and collect samples, creating efficient mining operations. Their cooperation makes large-scale mining on moons and asteroids feasible. These drones could transform space exploration and even provide Earth with valuable resources, supporting sustainable space infrastructure and colonization. In-space resource processing. In-space resource processing is transforming space mining by refining materials directly on asteroids or the moon, without returning raw resources to Earth. This approach eliminates the costly transport of unprocessed material, allowing only valuable, ready-to-use materials to reach Earth or be used in space manufacturing. From fuel to construction materials, in-space processing will change how we think about mining and building in space. The most exciting part is the development of mini-refineries that work in zero gravity and harsh conditions. These refineries are compact, self-contained systems that handle every process from crushing to extraction. Using solar furnaces, they harness the sun's power to reach the high temperatures needed for melting metals and extracting oxygen, crucial for both breathing and fuel. The challenge of refining in zero gravity has led scientists to invent new methods. With no gravity to separate materials naturally, techniques like magnetic separation, electrostatic processes, and centrifugal systems simulate gravity to process materials. These innovations ensure efficient operation even without Earth's gravity. Once refined in space, materials have countless applications. Imagine building satellites, space stations, or lunar habitats with locally sourced materials, reducing dependency on Earth. This advancement could establish a self-sustaining space economy. Future missions might even create tools and structures from these resources, making deep space exploration more feasible. Autonomous cargo logistics. Autonomous cargo logistics is revolutionizing space transport between Earth, the Moon, and beyond. Imagine automated cargo ships navigating space independently, handling every step of transport without human pilots. This system, powered by AI and robotics, is already making space exploration more efficient and sustainable. A key advantage is continuous operation, as these ships don't need life support or brakes. This allows for regular cargo movement, essential for long-term Moon or Mars missions needing steady supplies. Autonomous cargo can create a reliable supply line, delivering essentials like fuel and building materials. Technology like advanced navigation and AI-driven decision-making makes this possible. Sensors allow these ships to avoid obstacles, adjust course, and dock without intervention. If an issue arises, onboard AI can make split-second corrections, ensuring resilience in space's unpredictable environment. These systems are especially impactful for asteroid mining, transporting materials from asteroids to processing stations autonomously. Fleets of these ships could make large-scale space mining feasible and continuous, supporting infrastructure in space itself. More than logistics, autonomous cargo is building a connected space economy. Ships could deliver asteroid resources to space stations for in-space construction, sustaining operations without relying on Earth. This innovation lowers costs and risks, making ambitious exploration and human expansion into the solar system more attainable. Resource mapping and targeting with AI. AI-powered resource mapping is revolutionizing space prospecting by pinpointing valuable resources on asteroids, the Moon, and Mars. Imagine AI scanning celestial surfaces, quickly identifying mineral-rich or water-laden areas with high precision. This tech enables us to locate resources accurately, removing the guesswork from space exploration. AI systems analyze data from remote sensors, satellites, and rovers, recognizing patterns indicating resources. Using spectral analysis, which reads unique light reflections from minerals, AI rapidly maps out potential resource locations. This technology, already successful on Earth, could change space exploration. Paired with real-time data processing, AI can adjust plans instantly as new data streams in. For instance, if a rover detects platinum, AI alerts mission control, allowing teams to focus on that area. This AI acts like a virtual team of geologists, strategizing in real time. Resource mapping with AI also enhances mission safety. Space is hazardous, and knowing precise locations minimizes risky exploration, conserving fuel and resources. Targeted exploration reduces the chances of equipment damage or landing issues, creating safer missions from the outset. AI resource mapping aids in establishing outposts, identifying ideal locations with accessible water or minerals. A Mars base, for instance, could rely on nearby ice, supporting self-sufficient operations. For asteroid mining, AI identifies the richest targets quickly, optimizing mining plans before missions launch. AI-driven resource mapping makes space exploration smarter, safer, and more strategic, setting the stage for sustainable human presence beyond Earth. Water harvesting and fuel production. Water harvesting and fuel production in space is rapidly becoming an essential technology for exploration. Imagine extracting water from the Moon or asteroids and converting it into rocket fuel, allowing astronauts to refuel in space instead of carrying fuel from Earth. This breakthrough would save costs and enable longer missions to the Moon, Mars, and beyond. Water is surprisingly abundant on the Moon and in certain asteroids, with significant ice deposits found at the Moon's poles and water trapped in asteroid minerals. By harvesting, purifying, and storing this water, we can generate both drinking water and fuel. Through electrolysis, water can be split into hydrogen and oxygen, the components of rocket fuel. Robots equipped with drills and heaters would extract ice or hydrated minerals, turning them into vapor and then liquid water. Using electrolysis powered by solar panels or nuclear energy, they would convert this water to fuel directly in space. This sustainable process generates fuel exactly where needed. The benefits are immense. Rockets wouldn't need to carry round-trip fuel, allowing greater travel range. Lunar refueling sites would let rockets refuel and continue to Mars or other distant destinations. This approach, known as in situ resource utilization, could make interplanetary exploration feasible. Reducing dependence on Earth enables new mission strategies and lowers costs, potentially making space travel more accessible. With water harvesting and fuel production, we're moving towards sustainable exploration and even future colonization. This technology is bringing us closer to a future where humanity thrives throughout the solar system. 3D printing in zero gravity. Additive manufacturing, or 3D printing in space, is revolutionizing how we approach space exploration. Imagine astronauts printing tools, parts, and even structures directly in space instead of waiting for supplies from Earth. This technology enables a flexible, self-sufficient setup, especially in zero gravity. 3D printing uses layered materials like polymers, metals, or regolith to create objects. Unlike traditional manufacturing, which requires bulky machinery, 3D printing is compact and efficient, perfect for space missions with limited space and weight. NASA and Made in Space have already developed a 3D printer for microgravity, with astronauts on the ISS producing over 200 parts since 2014. This flexibility lets astronauts adapt to issues immediately, a crucial advantage for long-term missions to Mars. Looking to the future, 3D printing could enable building habitats on the Moon or Mars using local materials. Lunar regolith, for instance, could become walls, floors, or protective barriers, reducing transport costs. Autonomous 3D printers, aided by robots, could build habitats on Mars even before astronauts arrive. Additive manufacturing also simplifies repairs, allowing astronauts to print replacement parts and recycle broken ones. Recent advancements even allow for printing complex electronics and sensors on demand. This technology makes space exploration more sustainable, helping humans adapt quickly and explore further into the cosmos. Legal and environmental frameworks. Legal and environmental frameworks are gaining importance in the world of space mining. Humanity is close to accessing vast space resources, like rare metals and water from asteroids, but ensuring responsible, fair, and sustainable use is essential. The 1967 Outer Space Treaty established that space is the province of all mankind, meaning no nation can own celestial bodies. While companies can mine resources, they can't claim ownership of celestial bodies, creating questions about responsibility for environmental or legal issues. The Moon Agreement of 1984 proposed equitable sharing, but key players like the US, Russia, and China haven't signed, so it lacks global weight. Recently, countries like the US and Luxembourg passed laws allowing companies to own mined resources, sparking concerns about a space rush. The Artemis Accords, led by NASA, promote peaceful space exploration and resource sharing, but lack universal adoption, leading to potential legal conflicts. Environmental risks are also significant. Space mining could create debris fields, making space more dangerous for future missions. Experts advocate responsible mining practices and waste management standards to prevent additional space junk. Proposals suggest mining companies could take responsibility for debris cleanup, preventing dangerous chain reaction collisions, or Kessler syndrome. Ethical concerns have also emerged, with some suggesting that space should be protected like Earth's natural parks. This view questions if space mining should maximize resources or follow a leave-no-trace approach. Moving forward, we'll likely see a combination of international treaties, corporate responsibility, and environmental standards guiding sustainable space mining. Space mining's future is exciting, but requires careful legal and environmental management. That wraps up our journey through the incredible innovations transforming space mining. Each of these advancements brings us closer to a future where the resources we need are right at our fingertips, even millions of miles away. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the cutting-edge wonders of the world with us. Hey everyone, welcome back to InnoVision Tech. Today we're exploring artificial intelligence, a technology that's transforming our lives from smart assistants to personalized recommendations in ways we couldn't have imagined a decade ago. But along with these incredible advancements come serious risks that we need to be aware of. So we're uncovering the 7 most critical AI threats you should know about. Get comfortable, because we're diving deep into the hidden dangers of AI and revealing the risks that could shape our future. Data poisoning, the silent killer in AI training. Data poisoning is a major hidden threat to AI, often called the silent killer in AI training. Imagine AI models as sponges, absorbing vast amounts of data to learn and make decisions. But if someone contaminates that data, things can go very wrong. In simple terms, data poisoning happens when malicious actors feed corrupted or misleading data into AI systems during training, like giving a student the wrong textbooks on purpose. As a result, the AI learns from false information and may start making harmful or incorrect choices. For example, consider a medical AI designed to diagnose diseases. If cybercriminals poison its data with misleading information, it might begin misdiagnosing patients, putting lives at risk. The threat goes beyond healthcare. In fields like finance, security, and transportation, even minor data contamination could lead to disastrous outcomes, like stock market algorithms making faulty trades or security systems failing to detect threats. The worst part is that data poisoning often goes undetected until it's too late. AI systems can't detect manipulated data easily because they lack human judgment. As AI becomes more embedded in daily life, from smartphones to cars, the risk of data poisoning grows. Military applications of AI add another layer of concern, as adversaries could poison datasets for surveillance drones or automated defense systems. To combat this threat, organizations must invest in tools that can detect data poisoning early. Monitoring systems that alert experts to suspicious changes in data are essential to prevent corrupted data from impacting critical decisions. As AI's influence expands, ensuring data integrity has become vital. Adversarial attacks, the invisibility cloak for AI. Adversarial attacks, often called the invisibility cloak for AI, represent a serious threat. These attacks involve attackers subtly altering input data to mislead AI models. The surprising part is that these changes are often invisible to humans but can cause the AI to make critical mistakes. For instance, an image of a stop sign might be tweaked just enough to cause an AI-powered self-driving car to misread it as a speed limit or yield sign. This exposes a key weakness in AI. It relies on pattern recognition rather than true understanding. Adversarial attacks don't require extensive hacking. They're more about tricking AI by exploiting how it interprets data. This could involve altering images, tweaking audio files, or tampering with text data. Real-world examples exist. Researchers have used adversarial attacks on facial recognition systems by making tiny pixel-level changes to cause misidentification. This has significant implications for security, as it could enable identity theft or unauthorized access. The risk extends beyond privacy to public safety, especially as AI becomes more integrated into defense systems. Imagine if adversarial input could mislead a drone or missile guidance system, causing unintended and potentially catastrophic actions. Despite the serious threat, countermeasures against adversarial attacks are still in early development. Researchers are working to build AI models that can detect and reject these deceptive inputs. Making AI models more transparent is another approach to help humans understand decisions and catch discrepancies early. As AI adoption grows, staying ahead of these threats is crucial to ensure system security and reliability. Autonomous weapons machines. Making life-and-death decisions. Autonomous weapons represent one of the most chilling AI threats, as they are systems capable of making life-and-death decisions independently. These AI-powered weapons can identify, target, and eliminate humans without any oversight, essentially deciding who lives and who doesn't. While some argue they could reduce the need for human soldiers and lower battlefield casualties, the ethical and moral implications are profound. The biggest danger lies in handing over life and death decisions to machines, which could operate autonomously and cause mass casualties without human intervention. This raises a terrifying prospect, especially if these weapons fall into the hands of rogue states, terrorists, or criminal organizations. Rapid advancements in AI make this risk more urgent, with autonomous weapons potentially arriving sooner than expected. Current military applications already use AI in surveillance, drone strikes, and reconnaissance, bringing fully autonomous weapons closer to reality. Without human oversight, these systems could escalate conflicts and fail to avoid civilian casualties. They lack the moral judgment humans possess, which is essential in high-stakes situations. Additionally, there's the risk of malfunction or hacking. An autonomous weapon that malfunctions or gets hijacked could trigger unintended wars or catastrophic outcomes. Because of these concerns, experts are calling for international treaties to regulate or ban autonomous weapons. The debate continues, but as AI technology advances, the urgency to address this issue grows. It's a crucial conversation we need to have now to prepare for the consequences of machines making such critical decisions. AI bias, reinforcing discrimination. AI bias is a significant threat that often goes unnoticed, as it reinforces discrimination and social inequalities. AI systems learn from data that reflects our world, including its biases. So if the data is biased, the AI will likely be biased too. A well-known example is facial recognition technology, which studies have shown often struggles to accurately identify people of color, especially women. This bias happens because these systems are often trained on datasets primarily featuring white male faces, making them less accurate for others. In criminal justice, AI algorithms predict reoffending likelihood, impacting sentencing and parole decisions. When these algorithms are biased due to the data or their design, certain groups, often minorities, face unfair treatment with serious real-life consequences. Hiring practices are also affected, as AI systems are increasingly used to screen job applicants. If trained on historically biased data that favored male candidates, AI may continue that trend, unfairly rejecting qualified candidates based on gender or race. To address this, companies must actively identify and mitigate AI biases as AI's role in decision-making grows. This involves ensuring that training data represents diverse populations and regularly auditing AI models to avoid reinforcing harmful stereotypes. Making AI fair and inclusive is crucial for everyone to benefit from technological advancements, not just a select few. It's a pressing issue that needs to be tackled as AI becomes more integrated into everyday life. Privacy invasion, big data, big problems. Privacy invasion, as AI gets smarter, is a growing threat due to the vast amounts of data it can collect, analyze, and use. AI processes unprecedented amounts of personal information, including browsing habits, location data, social media interactions, and biometric details. This capability allows AI to create detailed profiles of individuals, leading to targeted ads and personalized recommendations, but also raising privacy concerns. The main issue is mass surveillance, where governments or corporations could potentially track people without their consent. The use of facial recognition in public spaces has fueled debates about balancing security and privacy. Misuse is another concern. Data in the wrong hands can be exploited for identity theft, blackmail, or social engineering. AI could analyze social media data to predict and manipulate behaviors, giving companies or political entities influence over decisions without public awareness. Data storage security is also a concern, as breaches could expose sensitive information on millions of people. Different countries have varying standards for data protection, creating an uncertain regulatory environment. To address these concerns, stronger regulations governing AI and data privacy are needed. Consumers must also become more aware of how their data is being collected and used by AI systems. Protecting personal privacy as AI becomes more widespread will be one of society's biggest challenges, requiring collective effort to ensure necessary safeguards. AI in cybersecurity, an arms race between hackers and defenders. AI in cybersecurity is a high-stakes arms race between defenders and attackers, where AI serves as both a shield and a sword. Artificial intelligence is transforming cybersecurity by detecting and preventing attacks more effectively than ever before. AI-powered systems can analyze vast network traffic, spot suspicious patterns, and respond to anomalies like data spikes or unauthorized access in real time. While AI bolsters defense, cybercriminals are also using it to create advanced, harder-to-detect malware, sparking an ongoing arms race. Attackers are now developing AI-enhanced malware that adapts to its environment, modifies its behavior, and learns from failures to evade detection. They can also use AI algorithms to probe systems, identify weaknesses, and exploit them more effectively. AI has elevated phishing attacks as well, generating highly personalized messages by analyzing social media and writing patterns. This makes phishing attempts more convincing, increasing the likelihood of success. AI also enables automation in cyber attacks, reducing the time and resources needed for large-scale attacks, which could overwhelm traditional defenses. To keep up, cybersecurity professionals must evolve their tactics, using AI systems that can stay ahead of attackers. Cybersecurity firms are increasingly adopting AI tools that learn from past attacks, adapt to new threats, and act autonomously. As AI continues to shape both defense and cybercrime, it's a double-edged sword that must be handled with caution. AI governance and ethical dilemmas. Who controls AI? AI governance and ethical dilemmas present critical challenges as artificial intelligence becomes more powerful and widespread. The question of who controls AI and how to ensure its responsible use is pressing. Without regulations, AI could be used in ways that harm individuals and society, from privacy invasion to biased algorithms, making governance crucial. A key ethical dilemma is AI's potential to infringe on human rights. AI-driven surveillance, like facial recognition, can enhance security but also raises privacy concerns, with some governments using it for mass monitoring. Without oversight, these systems risk compromising individual freedoms under the guise of security. AI could also worsen social inequalities, as biases in training data can lead to discrimination in hiring, policing, or healthcare. Creating transparent, accountable AI systems is essential to prevent unfair treatment and ensure AI benefits everyone. The concentration of AI power in a few tech companies raises further issues, as these entities hold significant control over how AI is used and who bears responsibility when harm occurs. Job displacement is another concern, as AI may replace millions of jobs, necessitating collaboration to retrain workers and equitably distribute AI's benefits. The risk of AI misuse by bad actors, including weaponization or autonomous systems beyond human control, highlights the need for regulation. Global cooperation among governments, companies, and civil society is essential to establish ethical standards and frameworks that ensure AI serves the greater good. By raising awareness and taking proactive steps, we can guide AI development in a way that benefits society as a whole. So there you have it, the 7 critical AI threats shaping our future. While AI brings remarkable benefits, we must remain vigilant about its risks, balancing innovation with ethical responsibility. If you found this video insightful, give it a thumbs up, share it, and don't forget to subscribe to InnoVision Tech for more tech insights. Stay curious and let's keep exploring. Have you ever wondered what it would be like to travel through time? Imagine jumping forward to see the future, or going back to fix a mistake. What would that even look like? Time travel has fascinated humanity for generations, inspiring countless books, movies, and wild theories. But did you know there are actually different kinds of time travel? Join us as we dive into the 8 types of time travel, exploring how they work, their weird effects, and the incredible stories that come from them. So buckle up for a journey through the dimensions of time. Join us as we unravel the mysteries of time travel and discover what's truly possible. Fixed timeline theory, the unchangeable path. This theory is pretty straightforward. Basically, no matter what you try to change in the past, the future stays the same. You can go back and mess around all you want, but the timeline will always course correct to make sure everything ends up how it was meant to. It's kind of like time is set in stone. Imagine this. You go back in time to stop a disaster, but it turns out that in trying to stop it, you actually cause it to happen. Sounds frustrating, right? But that's the essence of this theory. Your actions in the past are already part of the future, and there's no way to escape that. Movies like The Terminator or 12 Monkeys are great examples of this, where the characters think they're stopping something catastrophic, but their actions end up being the very thing that makes it happen. The real mind-bender here is the idea that maybe everything is already written. Every choice, every action, it's all set in motion and we're just playing out the script. Is free will just an illusion? Are we all just along for the ride even though we feel like we're making choices? This fixed timeline concept raises all kinds of philosophical questions. If you can't change anything, does anything you do even matter? For some, that's a comforting thought. Everything is meant to be. But for others, it's unsettling, especially if you like the idea of having control over your destiny. To sum it up, the fixed timeline theory tells us that no matter what we do in the past, time will always find a way to make sure the future stays on track. It's kind of like a cosmic safeguard that keeps everything in line, whether we like it or not. Dynamic timeline theory, changing the future. This theory says that the past isn't set in stone, and if you go back and change something, the future does change. In this version of time travel, you've got the power to rewrite history, and that can have some pretty big consequences. A classic example of this type of time travel is Back to the Future. Remember when Marty McFly accidentally changes things in the past and his whole future is altered? That's dynamic time travel in action. You can tweak events and those changes ripple forward, affecting everything that comes after. It's exciting because it suggests you're not just an observer, you've got the power to make a difference. But here's where things get tricky. You've probably heard of the butterfly effect, right? It's the idea that even the tiniest change can have massive consequences. Step on a bug in the past, and maybe that small act changes the course of history, leading to a totally different present. It sounds far-fetched, but in the world of dynamic time travel, it's a real possibility. You never know how those ripples will play out. This type of time travel is all about responsibility. If you've got the power to change the past, how do you know what changes are the right ones? What if you make things worse? That's the big question here. Just because you can change things doesn't always mean you should. At its core, the dynamic timeline theory taps into our desire to fix mistakes and shape the future for the better. It's the ultimate what-if scenario, where every action you take could have far-reaching consequences. But with great power comes great responsibility, right? Multiverse theory, infinite possibilities. Multiverse theory opens up the possibilities. According to this theory, every time you make a change in the past, you're not altering your original timeline. Instead, you're creating an entirely new one. It's like taking a fork in the road and both paths exist simultaneously but in different universes. So, in this theory, there's not just one timeline. There are infinite timelines with every possible version of reality playing out somewhere. You might go back and change something in the past, but all that does is create a new branch of reality. Your original timeline stays untouched. Imagine stepping into a world where major historical events played out differently. Maybe dinosaurs never